So now we'll be moving on to parallel and perpendicular lines. And we'll start with parallel. And parallel lines, they either meet at all points or they never meet at all. But notice how I've drawn some parallel lines here. What do you think might be the relationship between the two? They have the same gradient. And you could test this out. Trust me, they're the same gradient. What may differ is the y-intercept, however. So a question you might get maybe is, okay, to this line, which you may have been given in the question or have had to find out anyway through working in a longer problem, there's a line parallel to this and it's through a point. Obviously they may give you the point, or that point may have come from working out in another question or in part of that question, whatever. And so what you would do is you would say the m, let's do an example. Y equals 3x plus 9. And we're looking for a parallel line to that through through 4/24. And so you would say m is equal to 4, and then, well, you can say y equals mx plus c, just to make it clear that's what you're trying to do. M is 4, and then 4 times 4. Sorry, m equals 3. I'm having a brain fart. M equals 3, sorry. 3 times 4 plus c equals 24. 12 plus c equals 24. C equals 12. So y equals, keep doing that, I don't know why, 3x plus 12. Quite simple. Parallel's easy. Perpendicular's a bit more difficult. Now what this means is we can use this symbol, and what that would imply is you've got 90 degrees. So yeah. And what do you think might the relationship be for this one? Well, one of them's positive and one of them's negative, so there's that. But what might actually be the actual relationship? And perhaps you could think about it like this in a way. This the point A, B up here, and then, well, suppose we could do CD down here. If we just made both of them negative, so we went that down here, and then that up here, it doesn't look all that perpendicular, does it? In fact, it's simply, I think it's, it doesn't turn at 90 degrees. But what we could do is, what if we did we instead tried to do the height of A instead. We took this bit and then we spun it around, tried to do it in a 90 degree rotation, and then we ended up like here, and then up here, and then we did the same down there, we would get a perpendicular line. Because when we rotate something, we actually just swap around x and y and make one of them negative. And so now we've gotten to the point where this is minus b, comma a. So the gradient here would be b over a if we're just going from 0. But now it's a over minus b. And if you multiply these two together, they will cancel out and give you -1. And this is also called being the negative reciprocal of each other, because reciprocal is you flip the fraction, negative is you add the negative sign. But they multiply together to get -1. So if I did the same thing here, y equals 3x plus 9, but you wanted a perpendicular line through 424, you'd have to, you maybe want to do this. M with the perpendicular symbol equals -1 divided by 3, so that's minus 1/3. And then you'd say -1/3 times 4 plus c equals 24. Oh, maybe I might just make that a nicer number. Let's do -3. It's -3, that's just 1 plus c equals 24. C equals 23. So y would equal -1/3 x plus 23. And they could get you to rewrite it in the form ax plus by plus c equals 0. So you'd do 3y equals -x plus 69. And then you'd put that on the other side, 3x plus 3y minus 69 equals 0. But also, depending on what they ask, they might want that. So that is a basic perpendicular line question you could get. Feel free to look up on the internet a more stringent proof on this. But if you don't really want to do that, just remember this. Negative reciprocal. Reciprocal, you flip the fraction, negative, add a negative sign. Okay? Simple as that. You remember that, you'll be fine. Next one, we'll move on to a bit of a special case of perpendicular lines, is the perpendicular bisector. So, sector means we sort of section things off. Think maybe section. So we're cutting it up. And then bi means 2. So we want to get into 2 sections. So that would be going down the middle, right? And what point is in the middle of 2 points? I think maybe that might be called the midpoint. And we did that last video. What's the midpoint? Yeah, m equals x 1 plus y, I don't know, x 1 plus x2 over 2, comma y 1 plus y2 over 2. And my 2's are horrible. And so if it wanted the perpendicular bisector of, say, okay, bisector of 1, 2, and oh no, let's think. Oh, what if I make this 1, 3? And then 6 and 13. Let's try that. So the first thing we would do, I'll move this to one side for now. Don't need it for now. M is equal to 13 minus 3 over 6 minus 1. And if you really want to just be extra careful, you write your formula. And that's 10 over 5, which is 2. And then I would write m perpendicular is negative 1 divided by 2, which is minus 1/2. And then I would do my midpoint calculation. Make smarter, not harder, and just bring this down. And that would be equal to 1 plus 6 over 2, comma 2 plus 13 over 2. So that's 7 over 2 and 8. And that's our point. And because that this line with a gradient negative 1/2, because that's the perpendicular gradient, is passing through the midpoint, we can use y minus y1 equals mx minus x1 to solve this. Y minus 8 equals negative 1/2 x minus 7 over 2 equals x plus 7 over 4 equals minus 1 over 2x plus 8 times 4, so that's 32, so it's 39 over 4. And again, you might be asked to go and do this. 4y equals minus 2x plus 39, and then do 2x plus 4y equals 39. Or even 2x plus 4y minus 39 equals 0, something like that. And so that's all I really have for perpendicular lines and parallel lines. When we get to circles, there may be a few more important things to note about that, but for now, we'll leave the next stuff to the next video.